Welcome student to my YouTube channel Bharat Chem Study. Today we are going to study about chapter 1 periodic properties and variations of properties for 10th standard of ICSE board. In this video, that is part 6, we are going to study about the topic electron gain enthalpy, definition, factor affecting it and its variation along group and period. So let's start with the topics. Electron gain enthalpy, also called as electron affinity. It is defined as the amount of energy released when an electron is added to an isolated gaseous atom to form a negatively charged ion. So when an atom gain electron, it will release energy. And when an isolated gaseous atom release energy to gain an electron, then this energy is called electron gain enthalpy. The equation for it can be represented as X, a gaseous element or atom which gain electron and to form M negative ion in gaseous form, and energy will be released for the gaining of this electron. The SI unit of electron affinity or electron gain enthalpy is also kilojoules per mole as that of ionization energy. The tendency of element to gain electron is called electron gain enthalpy or electron affinity. Now the factor affecting electron gain enthalpy: atomic size. Larger the atomic size, larger is the distance of the nucleus from the outermost shell. So the incoming electron feel less attraction from the nucleus and the electron gain enthalpy value decreases. The second factor is nuclear charge. Larger the nuclear charge, larger is the force of attraction felt by the incoming electron towards the atom. So larger is the electron affinity. Now the variation of electron gain enthalpy or electron affinity along group. Electron gain enthalpy or electron affinity decreases from top to bottom along a group. That when we move down the group, the electron gain enthalpy value or electron affinity value going to be decreases. The reason behind that on moving down the group, the atomic size increases, so the incoming electron feel less attraction from the nucleus, so electron gain enthalpy value or electron affinity value decreases. The variation of electron gain enthalpy along period. In general, the electron affinity increases on moving left to right along a period. The reason behind that, when we move along a period, the nuclear charge increases, so the incoming electron feel more attraction from the nucleus, and so the value of electron gain enthalpy or electron affinity increases. A note: higher the value of electron gain enthalpy for an element, higher is its ability to hold the additional electron. Then halogens group 17 have high value of electron gain enthalpy. Reason behind that group 17 elements have strong tendency to accept electron and become stable because they have lack of only one electron to attain noble gas configuration. So halogen gain electron easily to attain stable electronic configuration, hence the value of electron gain enthalpy is very high for halogen. Noble gases have very high positive value of electron gain enthalpy. That is, instead of losing energy, they will gain energy. That's why the positive value is used for noble gases. The reason behind that noble gases already have complete shell. They don't have any tendency to gain electron. But if we want to add electron, that electron will move to the next higher level, that a new shell is created. So energy is gained instead of lost. So that's why we can say the noble gases have high positive value of electron gain enthalpy. Here the sign positive means that they will gain energy instead of losing energy. One very important topic, that electron gain enthalpy of fluorine is unexpectedly less than that of chlorine. In the previous topic we have studied that on moving down the group, the electron affinity value will going to be decreases. That means fluorine is in the top of its group, so its electron gain enthalpy value should be higher, and chlorine is coming below fluorine, so its electron affinity value should be low. But unexpectedly, the fluorine has less value of electron gain enthalpy, but the chlorine have more value. The reason behind that, the size of fluorine atom is very small. As a result, there are strong inter-electronic repulsion. That means its inner electrons repel each other, and the nucleus of fluorine uses all its power to hold those electrons. As a result of which, the electron which is coming near to fluorine will not get more attraction from the fluorine. Therefore, the electron gain enthalpy of fluorine is less than chlorine. In chlorine, no such repulsion will be present. That's why the fluorine has unexpectedly less electron gain enthalpy value than chlorine. So now do some question from the topic. Arrange the following element in the decreasing order of their electron gain enthalpy. So these are the element given. And first of all, doing such question, we should identify whether it represent a group or it represent a period or it is a mixture. That should be identified first. So these are the elements of period 3 that we have identified, and after that we have to arrange them in the proper order of their period. So the correct order was sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. Now we already have studied that on moving along a period, the atomic size decreases and nuclear charge increases. So the electron gain enthalpy value or electron affinity value will going to be increases. So the electron affinity value increases from sodium to chlorine. It increased from sodium to chlorine, that means decrease from chlorine to sodium. So while writing the answer, we will write in the decreasing order of electron gain enthalpy or energy of this period 3 as showing with an arrow. Now if the question says that arrange the element in the increasing order of electron gain enthalpy, so we know that the correct order of period 3 elements is sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine, and we already have studied that on moving from left to right along a period, that is from sodium to chlorine, the nuclear charge increases and electron gain enthalpy value also increases. Therefore the increasing order of electron gain enthalpy or energy for period 3 is sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. In the same way, one more question is that arrange the element of group 17, that is halogen, in the increasing order of their electron gain enthalpy. So the correct order of group 17 is fluorine, chlorine, bromine, iodine, acetylene. And we know that on moving down the group, the atomic size increases and the value of electron gain enthalpy decreases. That is, electron affinity decreases down the group. But here, this is a special case for group 17, because in case of group 17, the electron gain enthalpy of fluorine is less than chlorine. So that should be always remember in this case while arranging group 17 according to electron affinity value, that chlorine having more electron affinity than fluorine. So the increasing order of electron enthalpy for group 17 is acetylene, iodine, beryllium and fluorine than chlorine. So chlorine having more electron affinity value, that it is written at the last. But if we have to arrange them in the decreasing order, then we know that on moving down the group, the electron affinity value will decreases. That means from bottom to top, that is from acetylene to fluorine, it should increase. But again, fluorine is less electron gain enthalpy than chlorine. So the correct order of decreasing written as this. So chlorine having the more, then fluorine, then bromine, then iodine and then acetylene. So this is the decreasing order of electron gain energy or electron affinity value for group 17. Similarly, if we have to arrange the element of group 1, this is the exact order of group 1 element, and we know that on down the group electron affinity value decreases. So this represents decreasing order of electron gain enthalpy, and from down to top the electron gain enthalpy value increases. Similarly, in case of electron affinity of group 2, the increasing order is from barium to beryllium and the decreasing order is from beryllium to barium. For period 2, left to right, so from left to right the electron affinity value will increase and from right to left it will decrease. So study the topic given in this video and do written practice for the arrangement of increasing or decreasing order of electron affinity value. In the next video, that is part 7, we will study about the electron activity, its definition, factor affecting it and its variation along groups and period. Please like and subscribe the channel for the latest update. Thank you.